in order to get to the next generation of throughput, it's going to require a breakthrough in either how you achieve higher speeds or how you can get wider I/O. And in fact, it'll probably require a breakthrough in both areas. And so this memory wall here, which is boxing in current technology, both on the speed and the interface front, is demanding a revolution in two areas. One is a revolution in signaling, and the other is a revolution in interconnect. So if you break the memory technologies into three major classes, you've got graphics, computing, and then the embedded area. And the speed and I/O count in each of those areas is really governed by the economics of the system that goes into. Power has now become everything, not only in mobile, but in computing systems. So let's look a bit more on what this means, say, for packaging and interconnect. About every 6 years, there's really a major evolution in packaging and interconnect technology. Back in the 90s, leaded packages like TSOP were really common. That's what DDR looked like. About 6 years later, in 2000, when DDR2 started to come out, you saw the transition to BGA packages. Now, with mobile memories, you're seeing mostly package-on-package architectures. And so the pitch of these interconnects has been getting steadily smaller. With the T-stop, you might see pins at, say, 3/4 of a millimeter. With the BGA packages, they started at 0.8. But now with the package-on-package interfaces, they're now down to 0.4 millimeters spacing between one ball and the next. So what's the next generation going to have to look like? If you're going to implement a direct die-to-die stack, that pitch is going to go from 0.4 millimeters down to 40 or 50 microns. Now, semiconductor technology can support this in some ways, but there's really new assembly infrastructure, there's new manufacturing techniques, there's new design and validation requirements that are going to have to go along with driving this next revolution in packaging and interconnect. And so what you're seeing in embedded mobile memory right now is a serious effort to develop what's called a wide I/O memory technology. This is something that will allow an interface starting at 512, really 1,000 signals will go between the controller chip and the memory. This is showing up in the computing systems in the use of so-called 3D stacking. And so here you'll have DRAM chips that are stacked one on top of the other. Even though they may only still be 8 bits wide, there's going to be stacks of 4 to 8 of these all in a single package. So compared to what's being done in the mobile area, that's relatively simple. But compared to what's been done in the past with mainstream memory, that's fairly ambitious. And so the embedded and mobile memory areas are really driving and the interconnect revolution that's going to be applied in mainstream computing and also in graphics interfaces. Wide I/O is defined to have 512 data lines going from chip to chip, and also a couple of hundred control signals. In fact, what wide I/O is really kind of a form of wafer scale integration in which you have 4 independent DRAMs, each on a single die. Each of those DRAMs is 128 bits wide, and then those die can be stacked one on top of the other, basically soldered together to produce an entire system with memory all in one package. This is really a serious attempt to breach the wide interface part of the memory wall. On computing systems, this is showing up as what is called 3D stacking. So this is an architecture in which you would have a simple buffer device at the bottom of a stack, and on top of it could go 2, 4, or perhaps even 8 memory devices. And these would might look very much like the current memory interfaces in that they might be only 4 or 8 or 16 bits wide. But that entire stack will then be put in a single package and have a look like a DDR3 memory. So this interconnect revolution, which is starting in the embedded area and showing up as wide I/O, the next generation, is going to be showing up in system memory as the 3D stacking configuration.